If a function has been given to you in standard form, we can find the vertex by identifying a, b, and c, and then using this formula for the x-coordinate. So if we're going to label h as the x-coordinate, like what we saw in vertex form, then that would be using the formula negative b over 2a. That will find the x-coordinate. Every vertex is going to have an x and a y, so to find the y-coordinate, we need to plug x back into the function so that we can get the output, its y-value partner. The a part of the standard form is the same as the a in vertex form. So a x minus h squared plus k. We're going to start out just by finding the vertex in this first problem. So I have 2x squared plus 8x plus 12. In this we have a as 2, b as 8, and c as 12. So the vertex, I'm going to start out as x equals negative b over 2a. There's our formula for the x-coordinate. Negative b would be negative 8 over 2 times a, so 2 times 2. Negative 8 over 4 is equal to negative 2. So now I know for the vertex, it has an x-coordinate of negative 2. The only thing we don't know is the y-coordinate, and so we find the y by plugging in negative 2. F of negative 2 is the same. So 2 times negative 2 squared plus 8 times negative 2 plus 12. You can use your calculator throughout all this, but whenever you're doing it, you do want to make sure that you're putting this negative 2 that you're substituting in there in parentheses. And we get 18. Oops. We do not get 18. I'm missing an 8 in here. Plus 8 times negative 2. We should get positive 4. All right. F of negative 2 is positive 4. That means when x is negative 2, the output is at positive 4. This is a vertex that it has a parabola that's opening up since the a value is positive. In this case, this is going to be a minimum at that vertex. In b, we have g of x is 24 plus 18x minus 3x squared. Notice how this is shifted around a little bit. The c is the first part of that function. Then we have b, x, and a, x squared last. It doesn't matter that it's in a different order, but it does matter that we put it in the right place when we're doing our vertex. So if I did negative b over 2a again, I'd have negative 18 over 2 times negative 3, since a was negative 3. That ends up being negative 18 over negative 6, which is positive 3. Then we want to find f of 3. So 24 plus 18 times 3 minus 3 times 3 squared. Again, plug this straight into your calculator. And we get 51. So the vertex in this problem would be at 351. This parabola is going to be facing downward because our a term is negative. That means it had to have been reflected over the x-axis. So this is going to be a maximum at that vertex. Go ahead and pause the video to try C and D, and then when you're ready, you can press play again. All right, so for C, we're still doing negative b over 2a. You have negative 10 over 2 times negative 2. So negative 10, that just becomes a positive 10, but that's 10 positive 10 over negative 4, which reduces to negative 5/2. Oftentimes you're going to want to keep these as exact values. So negative 5/2 works, Or you could say negative 2.5 because that decimal does come out nice. Had this been negative 5/3 or some number that's going to have a repeating decimal or non-terminating decimal, you're going to want to keep it as a fraction. So let's find the output when x is negative 5/2. I'm plugging in negative 5/2 for every single x, and then just probably using my calculator to figure this out. So -2 parentheses negative 5/2 squared minus 10 times negative 5/2 minus 16 gives me negative 7/2 as the output. So our vertex in this problem would be negative 5/2 comma negative 7/2. And as a decimal, that would be negative 2.5 comma negative 3.5. In D, same situation, do negative b over 2a. So I have negative 15 over 2 times negative 3, which ends up being positive 5/2 this time. So f of 5/2 again, but this time positive. So negative 3 times 5/2 squared plus 15 times 5/2 minus 22. And we use our calculator again. So negative 3 5/2 squared plus 15 times 5/2 minus 22 gives me a decimal negative 3.25. You can turn that back into a fraction. It gave me negative 13/4. If you don't know how to use this calculator to get it back to a fraction, there's a button right above the equals or the enter that will transfer this number back and forth between decimals and fractions. So our vertex would be 5/2 comma negative 13/4. Or as a decimal, since this does come out nicely, 2.5 comma negative 3.25. And now that we have a vertex, we could then start putting things into vertex form.